The ornithopter horns electromagnetic suspension and diamagnetic repulsive force. Common permanent magnets that are parallel, locally fixed onto a surface parallel within vector. Around its gorge of the permanent magnet, rectangle permanent magnet solid block, exhibiting a coil alongside to its gorge surfaces in a spiral like pancake coil, inductive coil, AWG 24, audio wire gauge 24, to a surface of copper, two of those as a pair, and covering the top part of the coil exhibiting a central magnet, I have an aluminum sheet, also an iron sheet. That is the set pair of the repulsive ornithopter blades. Thermoplastic flexi deformable plastic sheet, a paddle exhibiting a central magnet, metric range of a human head shape. Metal central coupled to the aluminum sheet, block metal, is phase voltage booster, power capacitor. The high voltage booster arcs and sends plasma ions to cross between one surface that is connected to the other is joined to a flat paddle that may deformate. Structure deformate as the change in structure as the bend or having flexibility. The module couple is of the copper sheet bearing the copper coil AWG audio wire gauge 24 and exhibiting a central permanent magnet facing upward to its repulsive side. The paddle end is fixed to the surface of the lower part of the curved metric range of the face shield to a pitch around the permanent magnet allows the two generating a charge and attraction. Thus, the central is repulsive, causing taser. Tasing one side, creating electrical energy. Ions within the central, the permanent magnet, 5 pounds, 786 ounces is the stop generating a charge, so that the repulsive force would then return away the blades from one another, pushing the frontal surface of the faceplate forward. The freedom as of the faceplate to move forward. Magnet common side to another permanent magnet common side. So, while the permanent magnet is introduced to the vector field of the permanent magnet, it moves the helmet forward. It's moving back because of the repulsive force. So the induction coil that is underneath here is sitting back current in return, forcing the kinetic energy to be greater than. But because this is a low cheap battery, 9 volt, is doing that, and it's operating 2 of them, and it's almost dead. So I'm really barely getting a tase out of it. Okay, the actuator, as far as the blade actuator, this is for the ornithopter faceplate, and see the permanent magnet localized with the magnetic coil, and I got to put another coil localized on the other side right here by this one, and see this one bearing a permanent magnet with a coil, and that will allow this to flap. Now the other flap panels is right there. Flat panel, this is the other part of the wing, the blade. This is the flapper that flaps. This is the frontal actuator, the frontal wing. I have copper and aluminum encased together, banded together over nickel neodymium that is central within here, and the nickel neodymium is central within the copper coil, bearing the aluminum and the copper overlay. And I have it here in a linear motion, a linear motor, which is like a solenoid. This bearing the same copper and aluminum, and it's over a permanent magnet. And a permanent magnet is coupled to a metal surface, an iron surface. This is sort of as light as a voice cord. It's very light. It's a voice coil of a speaker. So Therefore, I have the winding coils here to force the linear motion to force the kinetic energy of the permanent magnet to escape from the magnetic field as to move it out of the slot. But instead, what it does is it shifts the entire unit away, carrying the inertial mass on both sides. So, because the kinetic energy and the electrical winding energy is the kinetic energy of the magnet is greater than the electrical energy until the electrical energy overthrows the permanent magnet and forces it away, and the diamagnetic, which is in here, and the repulsive charge aluminum that also escapes from the magnetic field. So, therefore, here should be the pushing to lagging forward and back. However, this will be the strength to reduce the inertial mass and gravitational mass, weight of the object, through the kinetic energy of the fixed permanent magnet within the central, where the electrical winding energy will tug in vibration to try to force it out. But the kinetic energy will release the ions this way in that direction, which will also reduce the mass because of the kinetic microwave energy, like suspending two parallel repulsive magnets that are fixed on its common side against one another. So the bulge will force it forward in its kinetic energy as of the move in a linear motion. Now here, which enables it to wag to go close to and from the system. So I have it on both sides. Now this is the blade that goes inside of the cockpit. Now the cockpit area for here of the system, and it is applied here in a flexi bar, flat bar is applied locally to attach to here to strip down here, which will assist in the return wag. First, the magnets will have to be embedded onto the surfaces of underneath the blade, but the blade will oscillate from the frame. However, in collisions with the repulsive permanent magnets will cause this to bounce back as a how can I say, anti-shock repulsive force, so that when it lands on the body, it will then relax the electrical current, land on the body, and have some kind of a soft collision. So that's what the repulsive magnet is for, which is the reason why this does not land locally to the area. Now, the repulsive force, when applying the phase wires to the two ends, separating the winding coil, so that the repulsive magnetics, when it touches one another, will send a current driving through one coil and through another coil and cause it to separate with extreme force. So that's what the phase or the induction coil is for. Now, I have to apply the magnets central within vector of the permanent magnets, so that it can repulse it and lift it up and cause it to flap and wobble. So I'm going to try that right now and get that accomplished. My name is Jermaine Morton. Goodbye. To up a kick. So one is to force it to a vertical position, and the other to force it to a vertical lift. So the bottom is the vertical position axis, and the top is the vertical lift actuator.